This is a guided walkthrough for day number 19 from TryHackMe's Advent of Cyber 2024 event. The category over here is game hacking, and the title of the exercise is I merely noticed that you're improperly stored, my dear secret. All right, so let's read a little bit more about the storyline before we begin the exercise. Dirt on the mayor, the glitch needed more, but the dirt was protected by a pesky locked door. But no need for panic, no need for dramatics. The glitch would get through with these game mechanics. Glitch was keen on uncovering Mayor Malware's deeds. Today he would be sure he would find something neat. He knew the mayor had an office downtown where he kept his dirty laundry. The big old clown. He approached the site silently, not knowing that the door was closed so untimely. At the front of the door, a smart lock awaited. Glitch smiled because he knew it could be subverted. But oh, big surprise, the lock was eerie. A game controlled it. Glitch almost went teary. If you were wondering how this came to be, Mayor Malware himself will explain it quickly. Technology gets broken every day was his claim, but nobody knows how to hack a game. Will Glitch be able to pass through the door, or will he end up with 0 as his score? So what are today's learning objectives? So today we're going to be understanding how to interact with Executables API. We're going to intercept and modify internal APIs using Frida, and we're going to hack a game with the help of Frida. So today we're talking about game hacking. Even while penetration testing is becoming increasingly popular, game hacking only makes up a smaller portion of the larger cybersecurity field. With its 2023 revenue reaching approximately $183.9 billion, the game industry can easily attract attackers. They can do various malicious activities, such as providing illegitimate ways to activate a game, providing bots to automate game actions, or misusing the game logic to simplify it. Therefore, hacking a game can be pretty complex since it requires different skills, including memory management, reverse engineering, and networking knowledge if the game runs online. Executables and libraries. The executable file of an application is generally understood as a standalone binary file containing the compiled code we want to run. While some applications contain all the code they need to run in their executables, many applications rely on external code in library files with the SO extension. Library files are collections of functions that many applications can reuse. Unlike applications, they can't be directly executed as they serve no purpose by themselves. For a library function to be run, an executable will need to call it. The main idea behind libraries is to pack commonly used functions so developers don't need to re-implement them for every new application they develop. For example, imagine you are developing a game that requires adding 2 numbers together. Since mathematical functions are so commonly used, you could implement a library called libmaths to handle all your math functions, one of which could be called add. The function would take 2 arguments, x and y, and return the sum of both numbers. So the game's executable is going to reach out to the math library over here and have the math library do the calculations and return it to the game executable here. Note that the application trusts the library to perform the request operation correctly. From an attacker's standpoint, if we could somehow intercept the function calls from the executable to the library, we could alter the argument sent or the return value. This would allow us to force the application to behave in strange ways. Hacking with Frida. Frida is a powerful instrumentation tool that allows us to analyze, modify, and interact with running applications. How does it do that? Frida creates a thread in the target process. That thread will execute some bootstrap code that allows the interaction. This interaction, known as the agent, performs the injection of JavaScript code, controlling the application's behavior in real time. One of the most crucial functionalities of Frida is the interceptor. This functionality lets us alter internal functions' input and output, or observe their behavior. In the example above, Frida would allow us to intercept and change the values of x and y that the library would receive on the fly. It would also allow us to change the returned sum value that is sent to the executable. Let's take a look at a hypothetical example. In this example, a number is simply printed to the console. Okay, so we run this program over here, and it prints out hello 1 a bunch of times. What we want to achieve is replacing the value with an arbitrary one, let's say 1337. Before proceeding, we'll run Frida trace for the first time so that it creates handlers for each library function used by the game. By editing the handler files, we can tell Frida what to do with the intercepted values of a function call. To have Frida create the handler files, you would run the following command: Frida trace, and then the name of the executable, -i, and then asterisk inside these quotes. You will now see the handlers directory containing JavaScript files for each function your application calls from the library. One such function will be called sayHello, and have a corresponding handler at handlers libhello.so, sayhello.js, allowing us to interact with the target application in real time. We don't need to understand what the file does just yet. We will review this in a later task. Each handler will have two functions known as hooks, since they are hooked into the function respectively before and after the function call. On enter. From this function, we are mainly interested in the args variable, an array of pointers to the parameters used by the target function. A pointer is just an address to a value. On leave. Here, we are interested in the retval variable, which will contain a pointer to the variable returned. Okay, so we've got some code over here. Frida JavaScript script to intercept sayHello, interceptor attach, sayHello, on enter function, and then some variables, and on leave function, some other variables over here, including the return value. We have pointers and not just variables because if we change any value, it has to be permanent. Otherwise, we will modify a copy of the value, which will not be persistent. Returning to our objective, we want to set the parameter to 1337. To do so, we must replace the first arguments of the args array, args0, with the pointer to a variable containing 1337. Frida has a function called ptr that does exactly what we need: allocate some space for a variable and return its pointer. We also want to log the value of the original argument, and we have to use the function toInt32, which reads the value of that pointer. So we've got some more code over here, and what this code is going to do is hook the sayHello function from the libhello.so library. Okay, so what we're going to do is we're going to set the argument over here to the pointer which contains the value 1337. Okay. When we rerun the executable with Frida, we notice that we can intercept the program's logic, setting 1337 as a parameter function. The original value is logged as expected using the following command. So over here, Frida trace into this program right here, -i for intercept, and say something. Okay. So hello 1337, it says the original argument was 1. When the sayHello function is called, it prints out hello 1337, and the original argument was 1. Now that we better understand Frida's capabilities, we can return to Frida trace. We have already seen that it generates the JavaScript script to hook a specific function automatically. But how does it know which function needs to be hooked? The parameter -i tells Frida which library to hook, and it can filter using the wildcard, tracing all of the functions in the libraries loaded. Connection details. All right, so we can finally start today's exercise. So, do we need to start a VM today? Yes. Is there a split screen available? Yes. So to start the exercise, all we need to do is click on this green Start Machine button over here. And then we're going to see that the browser page splits into a left and right side pane. So while this machine loads up over here, and it's going to take about 2 minutes, what we're going to do is we're going to read up a little bit on what we're going to be doing in this task, so that we're ready to get going when this machine finally initializes. So let's navigate down here. Okay, so if the VM is not visible, okay, well, we don't need to know this. So try unlock me the frostbitten OTP. So this is the name of the game that we're going to be hacking today. It says you can start the game by running the following command on the terminal. So first we need to navigate into a directory and then run the command over here. There's going to be a game over here, and so we're just going to wait a little bit before we get going because the virtual machine is still initializing. Okay, so over here, what are we doing? It says you can start the game by running the following commands on the terminal. So this command right here. So we just need to copy the command, and then we go over to this control panel over here, click on it, then click on the clipboard button over here, paste in the command we want to run, and then close the clipboard. And then we're going to start up a terminal. So we can start up a terminal with keep this shortcut here, or this one over here. I'm just going to use this shortcut here. This starts up a terminal that we can put commands in. So we're just going to click into the terminal and then paste in the command. Okay, so after that, I'm going to hit enter. And this is going to start our game. So try unlock me, press space to continue. Let's do that. So the game's controls are very simple. We've got the arrow keys that move us around and the space bar that does interact and speak. So we can move around and we can talk to this penguin over here. Oh, it looks like we need to make this game a little bit smaller because I can't see the dialog windows. Okay, just a second. Okay, so I think I can resize this window. Let me do that. Can we resize the window? I hope we can. Otherwise, what I can do is I can resize the entire browser tab. Hold on. Make it smaller. Okay, so this seems a little bit better. I think we can... Okay, so let me try talking to the penguin again. Okay, do you have the number in the thingy? Great. This is where we have to input some sort of password, but we don't know what the password is. So we just have to enter a random value. Wrong number, you don't look like malware to me. Okay, great. All right, so we're going to close out this program here. And I think I can make the terminal a little bigger. Yeah, okay, great. All right, so what does it say? So exploring the game a bit around, you will find the penguin asking for the pin. We found the penguin. Terminate the previous game instance and execute the following frida command to intercept all functions in the libaocgame.so library where some of the game's logic is present. Okay, so we're going to run this command right over here. So we're going to run frida trace to figure out what the library is doing. So what we're going to need to do is we're going to need to open up the clipboard and paste whatever command we want to put into the clipboard here. After that, we're going to paste the command into the terminal and hit enter. Okay, so this started up the game, but it also started up this tracing function over here, which is tracing what is going on inside the game. So notice the output of this one, Z7set OTPI. This indicates that the set OTP function is being called during the NPC interaction, you can try intercepting it. Okay, so let's demonstrate this. So inside the game, we're going to move around and we're going to talk to the penguin over here. Welcome to Try Unlock Me. Okay, so we're just going to zip through this dialogue over here. Okay, and then when it's asking us to insert the OTP password here, we're going to notice here that the game indicates that this function was called over here, Z7 set OTP I. Okay, so indicates that the set OTP function is being called during the NPC interaction. You can try intercepting it. Open a new terminal and go to this folder over here. Okay, so we're going to open a new terminal over here, and then we're going to navigate to this directory here. So we just need to copy the directory, and then we're going to go over to our clipboard. We're going to paste this into our clipboard, and then we're going to close the clipboard. After that, we're going to use the cd command and then paste in the file location here. After that, hit enter. And then we can see in here, these are the JavaScript files that we're looking for inside this this library. Okay, so go here and then open Visual Studio Code by running this command here. So it's going to be code space dot. All right, so we're going to do that. So the command is code space dot and then hit enter. And that's going to start up Visual Studio Code. So it says here, at this point, you should be able to select the Z7 set OTPI JavaScript file with the hook defined. The I at the end of the setOTP function indicates that there is an integer that will be passed as a parameter. It will likely set the OTP by passing it as the first argument. To get the parameter value, you can use the log function, specifying the first elements of the array, args, and onEnter functions. Okay, so what do we need to do? We need to click on this right here, which is Z7 set OTPI.js. So click on that. Okay, and what we need to do is we need to insert something. We need to insert this instruction over here. So log parameter plus args, this code right here. So go ahead and copy that line. And it says your JavaScript file should look like the following. So what we want to do is we want to insert this after the log Z7 set OTPI. So after this line in the code here, we're going to hit enter, and then we're going to paste in this command right over here. So we're going to need to go to our clipboard and delete what's there, paste in the command here, close the clipboard, and then inside of Visual Studio Code, paste in this line, okay? And then we need to save this file. So to save the file, we need to go over to File over here, and then we need to select Save. So after we do that, then this code over here has been modified. So it says you should be able to log something similar. Okay, so over here, they actually mentioned the parameter and what the code to set to over here. So what we're going to do is we're going to minimize Visual Studio Code, and then we're going to click on the game. So the game is over here. We're going to click on it, enter the OTP and press enter. So I'm just going to put something and then press return, wrong number. And then we're going to do this again. So we're going to interact with the penguin again. Do you have the number in the thingy? Okay, then it goes over to here. When we go back to our terminal with the Frida program running, we're going to see that parameter equals this right here, 568237. So this number is going to be different for every instance. Every time this this function is run, there's going to be a random number. So we just need to remember this number here. It's going to be different for everybody. So 568, 237. So I'm going to 568, 237, and then hit enter. It says, ding, 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 welcome back, Mayor Malware. You may now proceed, and we get a flag over here. So I don't think we can copy this password, but what we're going to do is we're inside the TryHackMe page. We're just going to go down, and we're going to put in the first flag over here. What is the OTP flag? So we're going to type it in, THM, and then between the curly brackets, 1_tough_password, and hit submit. Okay, great. And then we're going to go back to where we were before. Okay, I think we were right here. Okay, so it says then you need to use that parameter as the OTP. The value changes over time, so yours will be different. Okay, so we've just done this. So we're going on to the next section. Try Unlock Me, a wish list for billionaires. Exploring the new stage, you will find another penguin with a costly item named Rite of Pass. So let's go ahead and click on the game and then proceed. So we're just going to go over to, we're going to use the arrow keys. We're going to proceed over to the right, and over to the right there's a new area over here, and there's a penguin over here that we can talk to. And the penguin says, you are now verified to be at least 1/3 of Mayor Malware. Congrats, okay? The second authentication factor is called a wish list for billionaires. Sounds shady, how does it even work? I'd be silly to tell you you could compromise the whole system. Oh, at least you are more security aware than the last guy. I am. All right. I'll explain it just this once because I like you. Mayor Malware is the only one in Wareville with the super ultra mega plat premium extra hyper plus card plan. This means he is the only one who could buy the coveted Flag 2 item from the store. Does he pay 1 million coins every time he needs to open his door? He does, but then refunds the product. I should be rich by now, if not for the cheap mayor. But hey, if you are having cash issues, you can always mine some coins from that old PC. Is there anything you'd like to buy now? So what we're going to do is we're going to try to buy Flag 2 over here, and we're going to press the ID of the item you want to buy, followed by return. So over here, we're going to press 3. We're going to type in 3 because we want this flag over here, and then hit enter. Checking your credit card. You don't have enough money. Use the PC to get more coins. Okay, so what just happened? The game lets you earn coins by using the old PC on the field, but getting 1 million coins that way sounds tedious. You can again use Frida to intercept the function in charge of purchasing the item. This time it's a little bit more tricky than the previous one because the function buy item displayed as Z17 validate purchase, III, has 3 I letters after its name to indicate that it has 3 integer parameters. You can log those values using the log function for each parameter trying to buy something. Okay, so let's demonstrate. So over in the Frida window over here, so Z17 validate purchase, this function over here, it has 3 integers associated with it. So this is a little bit more tricky. So what we're going to do is we're going to modify this inside of VS Code. So we're going to click on the desktop, and then we're going to go over to VS Code over here, Visual Studio Code. This is the icon we want to do. Click on that, and then we need to click on the validate purchase III.js library, the JavaScript file. So click on it, and then we're going to see here that on enter, we're going to log arguments and state, and on leave, we're going to log return value and state. So what are we supposed to do? We're going to log the values using the log function for each parameter trying to buy something. So this code over here, we're going to copy all of this code. Your JavaScript buy item file should look like the following. So what are we doing? So we're copying these parameters over here and we're going to insert it into the JavaScript code. So this code right here, after we've highlighted it all, we're going to copy. And then we're going to go over to the define handler on enter and insert this code here. So over here, we need to click on the control bar here, and we need to paste in this stuff into the clipboard, and then close the clipboard. So after that, we're going to go over to the define handler. We're going to go over to the first log over here, go to the end of the line, hit enter, and then we're going to paste in the 3 lines that log the other parameters. So after that, okay, so it looks like the indentation got a little bit stuck. So I'm going to keep on hitting space until these are all lined up. Okay, that's great. After that, we're going to save this file. So over here, we're going to click on File, and then we're going to click on Save. And then afterwards, we're going to go back to the game. So we're going to minimize VS Visual Studio Code, and then go over to the game. In the game, we're going to try to buy the item again. So the penguin here, we're going to press space, and we're going to try to buy flag number 2 one more time. So in the box, we're going to enter 3 and then hit enter. Checking your credit card, you don't have enough money, use a PC, okay. But we're going to go back to Frida over here, and we're going to see what happened. So we see here, parameter 1 is equal to 3, parameter 2 is equal to 1 million, and parameter 1 is equal to 1. So obviously the ID of the item that we're trying to purchase is parameter 1 here. Parameter 2 is the cost of the item. And the other one over here, I guess this is true or false. This is what I'm guessing what it is. But let's take a look. You should see something similar to this. By simple inspection, we can determine that the first parameter is the item ID, the second is the price, and the third is the player's coins. Oh, okay, so the third argument is the player's coins. If you manipulate the price and set it as 0, you can buy any item that you want. So it's going to be arguments 1. So this is argument 0 over here. If we set argument 1, which is parameter 2, and we set this to 0, that means we can purchase anything we want, even if we don't have very much in our wallet. Okay, so your JavaScript buy item file should look like the following, okay? So what we're going to do is args1 is going to be equal to ptr 0. So it's going to be equal to the 0 value over here. So we're going to copy this code here, and then we're going to go over to the clipboard. In the clipboard, we're going to take whatever is already there and delete it, and we're going to paste in this code. After that, we're going to close out the clipboard, and then we're going to go back to Visual Studio Code. So click on the desktop, and then go back to Visual Studio Code here. Inside of Visual Studio Code, so the on enter portion here, we're going to delete this parameter here that logs the parameters. We're going to delete all this. And then in its place, we're going to paste in the code that, oh, we didn't, okay. So let's put this in manually. Okay, so it's going to be args1 equals ptr0. Great. Let's just type this in. So args, and then 1 inside the square brackets, ptr, and then inside the parentheses, we're going to put 0. So what this is going to do is it's going to set the price of the item that we want to purchase to 0, which means we can purchase any item. After that, we're going to go over to File inside of Visual Studio Code, and we're going to save the file. After that, we're going to minimize Visual Studio Code, and then we're going to go back to the game. So in the game here, we're going to try to purchase the flag one more time. So we're going to try purchasing flag 2 over here. So ID is 3, hit enter. Checking your credit card. Welcome back, Mayor Malware. You may now proceed. We've got flag 2. THM credit card undeclined. Great. Okay, so we're going to enter the value of this flag before we proceed. So we're just going to go over to the bottom here. And what is the billionaire item flag? So we're just going to enter THM and then inside the curly braces, credit underscore card underscore undeclined. Okay, and then hit submit. Okay, great. We just need to go back up to where we were before. So it says, try unlock me, naughty fingers, nice hack. So it says the last stage is a bit more tricky because the output displayed by Frida is this over here, check biometrics, this function here. So it does not handle integers anymore, but strings, making it a bit more complex to debug. Okay, so let's demonstrate this by going back to the game. So we're just going to go over to the last area over here. And in the last area, we have to talk to the penguin here. And when we talk to the penguin, he says, just one more factor to overcome to finally become Mayor malware. The last authentication factor is biometrics. At last, a normal authentication factor, so whose eyes do I need? Eyes, this is a punch-based authentication system. Mayor malware has a very specific way of punching the keyboard that nobody can replicate. And here we go again with this madness. Should I punch my keyboard then? Well, you can gently put your hand on the keyboard, no need to get violent. I was worried for a second, now show me the keyboard. Put your fist on the keyboard. Naughty fingers, I see. Are you sure you're the real Mayor malware? Okay. So, all right, so we failed to authenticate, but let's take a look. So over in Frida over here, so they ran this function over here, check biometrics PKC. So let's take a look at what this means. So by selecting the JavaScript file named Z16 check biometrics PKC, you can add the following code to the onEnter function as you did previously to debug the content of the parameter. Okay, so it looks like what we're going to do is we're going to read the C string of argument number 0. Okay, so this one over here, we're just going to highlight this part of the code and copy it. And then we're going to go over to Visual Studio Code. So over here, go back to Visual Studio Code. And we're going to click on the check biometrics pkc.js file here. After that, we're going to click into the onEnter portion. And we're going to hit enter right after the log check biometrics. And we're going to paste in the code. So we need to go over to our clipboard and delete all the stuff here. Paste in the code we copied, then close the clipboard, and then over here we're going to paste in that code. Okay. All right. So now that we've inserted the new line into the JS code over here, let's go ahead and save out this file. All right. So save out the JS file, and then let's minimize Visual Studio Code. And then after that, we're going to go back to the game. So the game over here, we're going to do our biometric validation one more time. So talk to the penguin here. Please put your fist in the keyboard. Great. And then it tells us one more time that this is not the correct one. After that, we're going to go back to the Frida program. The Frida program says that the parameter from the biometrics check was this string right over here. So what does this mean? Let's take a look. So this output does not seem to be very helpful. You might have to consider another way. You can then log the return value of the function by adding the following instruction to the onLeave function. So we're going to take a look at what the return value is on the onLeave function here. So we're just going to copy this code over here. We're going to go and modify the file inside of Visual Studio Code one more time. So we're just going to modify the clipboard and paste in the instruction, close the clipboard, and then we're going to go over to the onLeave function here. So we're just going to hit enter after the opening curly brace, and then paste in the instruction. Okay, so log the value, the return value is this. Great. After that, we're going to save the file, and then we're going to minimize Visual Studio Code one more time. Okay, so after that, we're going to go back to the game, and in the game, we're going to do the authentication one more time. So the biometric authentication, we're just going to get that message. Naughty fingers I see. We fail it again, but let's take a look at what Frida was able to find. So it says the return value is 0x0. So this is 0, which means that a valid value would probably be 1 if we're going by true and false, 0 being false and 1 being true. So the value returned is 0, which may indicate that it is a Boolean flag set to false. So which value will set it to true? Can you trick the game into thinking that the biometrics check worked? The following instruction will set the return value to true. Okay, so retval.replace ptr1. So this is going to replace the return value when we leave from false to true. So let's copy the command here, and then go over to our clipboard. In the clipboard, replace the value, and then close the clipboard. Then go over to Visual Studio Code. In Visual Studio Code, in the onLeave function here, we're going to paste in this instruction here, retvalue.replace ptr1, and this is going to set the we're going to set the return value to 1, which is going to let us pass the check. All right, so let's finish the challenge now. Now that we've replaced all of the values inside this code here, we're going to minimize. Oh, sorry, we need to save the file. So we're going to go over to File and then click on Save. So over here, after we've saved out the file, we're going to minimize Visual Studio Code again, and then we're going to go over back to the game. In the game, we're going to talk to the penguin. Okay, please put your fist in the keyboard. Great. It's going to try to validate. And then it says, that's weird. You didn't punch the keyboard, yet the signature is correct. So if we go over to Frida, we see here that it says that the return value is 1. So 1 meaning true, which means we're able to pass the check. Mayor Malware would have hit it with all his might. Who are you, imposter? You can't fool me. Me? I'm the mayor. Yes, Mayor Malware, vote for me, please. Okay, and then, oh my bad, welcome mayor, we've missed you. And then we get the final flag. So THM, don't smash your keyboard. So we're going to insert this into the last answer field here. What is the biometric flag? We're going to type in THM, and then in the curly braces, don't underscore smash underscore your underscore keyboard, and then hit it submit. Okay. All right, so we've essentially finished today's exercise. So the last things we need to do is we need to answer these 2 questions over here. If you like today's task, you can practice your skills with the Memories of Christmas Past from Advent of Cyber 2023. So this is another cybersecurity module from last year's Advent of Cyber event. Just click on the complete button, and it says the second penguin gave pretty solid advice. Maybe you should listen to him more. So this probably has something to do with the extra exercises that are associated with this year's event, but we're not here to solve that. So we're just going to click on the complete box here, and then we've completed the task. We see that the task here turns green, which means we are finished. Okay, so that was a guided walkthrough of the Advent of Cyber 2024 event from TryHackMe.com, day number 19. And if you liked this walkthrough, please click on the like and subscribe buttons on the video. And until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.